2, 1, go. All right, so in order to find the specific gravity of this log that you see here as a function of HR, first you're gonna have to understand the term buoyancy, which is basically the weight of the fluid displaced, right? And an equation for weight is mass times the acceleration due to gravity, and to expand mass, you can do density times volume, and then you multiply the acceleration due to gravity. So if you're going to compare the weight of the log versus the weight of the water, you'll be able to find the specific gravity. So the equation for that would be the density of water times the area under water, so this part right here, times the length of the log times the specific, or times the acceleration due to gravity, and then you set that equal to the same thing for the log, which is pi r squared for the area. So then from there, you can go ahead and get started on the calculation. So here you see the face side of the log, and we'll go ahead and label the different dimensions. So you have the radius right here, you have h, which is, h is defined as basically the height above water of the log. You have r minus h, which is the radius minus the height, which is this section right here. And we'll go ahead and set x equal to this length, which is halfway between this point and that point, and then we'll say theta is this angle. So first you're gonna find x in relation to the r and h, and due to the Pythagorean theorem, you know that x is equal to the square root of radius squared minus r minus h squared. And then you can go ahead and expand that out, so you can do x squared is equal to r squared minus r minus h squared to get rid of the square root, and then you can add the r minus h squared to the other side to make things easier, and then from there you can expand, so x squared plus r squared, and then minus 2rh plus h squared is going to be equal to r squared. And here you see the r squares cancel, and you can go ahead and just add this back to the other side, subtract this, and then take the square root of that, and you'll get x. So x will be equal to square root of 2rh minus h squared. Okay, so now that we have that, we can then go and try to find basically the area of this triangle right here. So for the triangle, I'll label it as that. You're going to do, to find the area of a triangle, obviously it's 1/2 times base times height, right? So the base across is 2 times x, correct? So 2x, and then you'll multiply by the height, which is r minus h. So here, we can go ahead and plug in our x that we found, which will be 1/2 times 2, and then plug in the square root of 2rh minus h squared, and then go ahead and multiply all of that by r minus h. Here you see the 1/2 and the 2 will cancel to become 1. So your equation for the triangle is simply square root of 2rh minus h squared times r minus h. Okay, cool. So next part is you're going to try to find the area of the whole piece. So call it just the pi piece. So right here, we'll just label it as that. And we do know an equation, which is theta over 2 pi will be equal to the area of the sector. So area sector over the area of whole, so pi r squared. So this part's the sector. So if we go ahead and multiply this to the other side, we can then also do 2 theta because we're finding this whole side. So we'll do 2 theta over 2 pi, and then multiply that by pi r squared, right? Okay, so if we're gonna define theta according to r and h, we're gonna do, see how r is basically the hypotenuse, and r minus h would be the adjacent side. So we can do arc cosine, which will be arc cosine of r minus h over r. Cool, all right. So from there, we're going to go ahead and continue on and do r squared times the cosine, arc cosine of r minus h over r, and then minus what we found before. So the 2RH minus h squared, and then multiply that by RH. And the reason why we did that was because we're basically finding in between this section and this section is what, right here, right? So we're gonna subtract this from that, or this from that, sorry. And that's how we're gonna get that area. So, going from there, we're gonna go ahead and plug what we have into the equation that we started with up here, because we have the area now. So we'll do the density of water times the pi r squared minus, because we're subtracting from, because pi r squared is basically the whole thing. We're just going to subtract the area we just found to get everything underwater, correct? So we do pi r squared minus the r squared cosine -1 r minus h over r minus the square root of 2rh minus h squared times r minus h, and then we'll set that equal to the density of length times pi r squared. Okay, so now we are basically just trying to get this isolated. So we're going to divide pi r squared from both sides. So we will get the next part, which will be, we'll just go ahead and isolate it now, equals the density of water times, and here we see it becomes 1 minus, we'll just do 1 over pi here, cosine, arc cosine negative of 1 minus h over r, because you see that cancel, and we're getting it in terms of h over r. We're going to subtract 1 over, and then we'll just do pi r squared, subtract all that out, and here we're going to do something a little interesting in order to get it in terms of r, or h over r, like we were originally doing. So we're going to multiply r squared on top times 2rh minus h squared, and then we're going to divide it by r squared. So basically they cancel, but that's how we get it in terms of h over r. And then we're going to go ahead and multiply the same thing over here, r minus h over the radius. Okay, so we're almost done. We're going to go ahead and finish the step by simplifying it one step farther. So we'll do density of the log is going to equal the density of water. And here we can do the same thing, 1 minus 1 over pi times the arc cosine of 1 minus h over r, and then 1 over pi r squared. And here we're going to go ahead and just pull out this r over here. These will cancel, and we'll have 1 r on the outside, so we'll just pull it out now. Put it outside the square root here, and this will just be 2, and then we'll separate each one. So r squares will cancel, and it'll be 2 times h over r, and then you'll subtract h over r, and then we'll just square both sides because it's h squared over r squared. So that'll be all across, and then we'll finish by multiplying the 1, because they cancel, minus h over r. And that is the equation we're looking for. And as we know, specific gravity is basically, for this equation, will be equal to the density of the log over density of water. So now that we have it in terms of h over r, we can solve for the density of log and the density of water in order to find the specific gravity.